Okay, so we've also seen in an earlier example that you can get logs from the from pods. In this case, the busybox did nothing more but execute echoing hello world to the command line. So this is what's in the logs as it has been written to std out. We've also seen how to describe a pod, because there's interesting lifecycle information attached that we can use. And we've also seen that we need to delete the pod, otherwise we can't start a pod with the same name anymore. All right, so this is using the command line, as I said earlier in the context of namespaces, that often you want to declare something in a YAML file and then apply the declaration to the Kubernetes cluster. So declarative specification is a central idea in Kubernetes. So telling a Kubernetes cluster what to do in sense of create something, delete something, is basically all the imperative that you will utter towards the Kubernetes cluster, because you will tell the cluster most of the time with a specification exactly what you want. So you don't tell him create a pod, use that image by issuing a series of commands, as you would have done with virtual machines in prior automation technologies such as Chef, where the idea of the automation was to remote execute commands. So the idea with Kubernetes is different. The idea in Kubernetes is that you specify in a description language, in this case YAML, what the result should look like. And then you pass this specification to Kubernetes and let Kubernetes do the job. While this is for namespaces trivial and you don't see the value, you will see the value subsequently when we start using more advanced structures. So be a little patient. You will see the utility of that approach during the lecture. So specifically, you can create a pod from a specification, and it is also important that you become familiar with the way pods are specified, because even more sophisticated structures like replica sets will always require you to specify a pod structure. So again, the same specification structure will be used. So let's do that. So in order to create a pod declaratively, we'll create a file. Let's call them 10pod.yaml. And again, we have an API version, in this case version 1. We tell them what kind of object do we want to create. In this case, it is a pod. Again, the name is part of the meta information, so it's could be other attributes as well, but in this case, the name will be good enough. This is the actual specification of the pod. So you can see that you've had a similar structure in the namespace. You also had an API field, you also had a kind field, you also had a metadata field, and there was also, I'm not sure about the specification, but in a pod you need a specification. And you will see that for replica sets and so on, there will also be a specification, and they can be nested, so that the specification of one kind also creates the specification of another kind. We'll come to that. In this case, you can see the specification of a pod requires to specify containers, and you can also already see plural, because there could be multiple containers. So in YAML, you build a hash by nesting the structure like this, and you create an array when using dashes like this. And under the array, there's a hash So you could basically copy this entire segment and you'd get another container. This also denotes a array. You can see that from the square brackets. And is an alternative to using the dashes. So in this case, where there's only one element, the square brackets are more comfortable to use. So the specification here says, I want to have one container. I want to use the BusyBox container. And do you also see that I'm not specifying a registry here? I'm not specifying user within a container registry. So what do you think is going to be used as a registry? Exactly, the Docker Hub. It's because it's basically the same default configuration as with Docker. Docker Hub is the default registry. We are not using username, which means this is an official image. BusyBox is a very small Linux based container image. And if you look up BusyBox, so you can see that there are a lot of tools in the BusyBox BusyBox tool that you would otherwise have to install separately as commands. About BusyBox, the Swiss Army knife of embedded Linux. I think there's documentation, command help. So this is the list of commands that is included in BusyBox, which is basically what you'd expect from a Linux system to be present as commands. This one is particularly nice because it is very, very small and compact. So it's basically providing you a subset of the GNU utilities, I think, and it's nice. So small but nice. All right. So we use that BusyBox image, official image, located at the container registry Docker Hub. We're giving it a particular command. This would be echo, and the argument for the command is a single string hello world. And we don't want to restart the container. All right. So that means if the container has failed, not a new container will be created with the same structure, but it will just be remain terminated. So again, kubectl apply from file, and then passing in our YAML file. And so far, so good. Now, there's one thing to mention here, like BusyBox created. What does this mean? Kubernetes is not telling you at this point that this has been successful in the sense that the actual task has been carried out successfully, with the task being creating the pod. What happens here is that you specified an API object of a certain kind. The kind is BusyBox, is pod. The object of the class or the kind pod is to be created by Kubernetes. So what you're telling with kubectl apply Kubernetes is, please Kubernetes, I have an object definition. Please take that object definition and create that object for me. The Kubernetes API then receives that request and says, all right, I understand what you want. You're saying you want to create an object of the kind pod with the following specification. I got that. I'll do that for you. So never mind. So it will say back to the client, done. What it meant is that you passed on the declaration that this object has been created in the sense that the object specification has been created, and that Kubernetes will then do whatever it finds necessary to actually fulfill that request. And there are two different things. The first thing is to say, well, I want a house. Here's my building plan. Blueprints. It's made by an architect. This is what I want to have. And the construction company says, well, thank you very much. We kindly will process your request pretty soon. I got you. But the house has not been built yet, because this is a separate process. If the construction company knows what they are doing because they know how to handle that particular blueprint, in this case, how to handle creating a pod, which is a native Kubernetes structure. So there will be a controller within Kubernetes acting upon it. So within Kubernetes, there's going to be a notification, an event, so to say, saying, well, you know, there's a new object. You have to do something about it. And the whole thing of declaring that I want to have a pod is the separation of the declaration and the actual fulfillment of the declaration. So within Kubernetes, there's a controller reading your object definition and now try to make sense of it by creating a pod. So what does this mean? It means that this means nothing but that Kubernetes got your object specification, the pod specification in this case, and it somehow took responsibility for creating it. But you have to watch whether this has been successfully. That's why you will kubectl get pods to see whether this has worked. This is important that you get it. Only by looking at whether this actually worked, you will find out whether it actually worked. So in this case, the pod has been completed. It did the same thing as we did before, kubectl logs busybox, and there's your hello world. Okay, but this is the first time we see how Kubernetes actually works, because the step could have failed, although this one said successful. So we could, for example, copy that pod definition, call it busybox2, and misspell the command. Kubectl apply. By the way, I'm using numbers in front of file names for two reasons. First, files will be ordered in lexicographic order. So basically 1, 2, 3. I'm using steps of 10 so that I can insert elements into that sorted list. So especially when I create a series of resources that should be executed in a particular order, and I want to split them into different YAML files, I'm using numbers so that it is absolutely clear in which order they should be executed. And it has also the interesting or the handy advantage that kubectl apply -f, I just have to type the number. The number is unique already, and then using tab I have the auto completion. So just for the productivity nerds under you.